Welcome to October 1st LeetCode Challenge. Longest common subsequence. Given two strings, text1 and text2, return the length of the longest common subsequence. If there is no common subsequence, return 0. A subsequence of a string is a new string generated from the original string of some character. Can be none, deleted without changing the relative order of the remaining characters. For example, ACE is a subsequence of the ABCDE, where we just get rid of B and D there, and we get the ACE string being the common subsequence. A common subsequence of two strings is a subsequence that is common to both strings. So for example number 1, we have text equals ABCDE, and then text 2 equals ACE. So the most common sequence string, with only deleting some of the characters in, let's say, text 1 would be ACE, and then we have the longest one would be 3. The output would be 3. The longest subsequence is ACE, which is including both of them. If both text1 and text2 are the same, then we would just return the maximum length of one of them. And then if we have here the two sequences of both text1 and text2 are different, we just return 0 because we have nothing in common. Constraints: we have text between text1 and text2 length would be between 1 to 1000, and text1 and text2 because it's only lower English characters. So it's a medium-sized medium question. So this is quite a classical dynamic programming question. So the first thing I'm going to do is so our answer is going to be basically our dynamic programming array at index ij. It's going to be our answer, and basically we want to return the substrings between text from the beginning to the very end, and then of text1 and text2. So let's start off with initializing. So the trick with the dynamic programming is that we don't want to return, if we have none of them in common, that means we want them to be equal to 0, but the dynamic programming requires you to have a initialize the same. So what we could do is do text1, initialize that to, let's say, a symbol that we're not going to use, call it exclamation mark, or a string of symbol there, just exclamation mark will be good, plus text1, then text2, text2. This is so that we could compare them together if they are not equal, right? Just to avoid the edge case there. So the next thing we want to do is find the length of both of the texts. So it'll be basically length of text1, length of text2. So now we have that. Now we initialize our dynamic programming array, which is all going to be 0 times the length. Oops, do what's it called, a list comprehension here, times n. So it's going to be an array for each space in the range of m. So we got a two-dimensional array there, and then we first want to initialize dynamic programming position 0, 0 to 1. So this is standard dynamic programming initialization. So next what we're going to do is do a for loop between index I, j for the text1, text2 in the product of range m to range n. It's not the most pretty type of for loop iteration here, because this will basically be a big O of m times n time complexity, but I'll talk about that after if we get accepted. So if text1 at I is equal to text2 at j, then they are the same character. Then what we do is we update our dynamic programming array at index ij to be the dynamic programming array at the previous location. So that'll be I minus 1 and j minus 1 plus 1, right? Because we want to do the one afterwards. So that's the case if they're not the same, then else. Then what we do is we find whether the previous dynamic programming array is greater than what we had right now. So that'll be updating dynamic programming at ij to be the max of dynamic programming at index I minus 1, j at j, or that would be dynamic programming at I minus j. If I have this correct, let's see, I, then this is j minus 1. Because I'll talk about that in more detail actually when I return the dynamic programming array at positioned -1, -1, -1. This is our last basically thing we enter inside our dynamic programming array. So while that's running, so the first condition is that if both the text1, what am I doing? DP. So if both texts are the same at each index, then we pretty much make them equal to each other. Then we basically update the dynamic programming at index ij to be that location plus 1. Alright? That means we add 1 to the dynamic programming array. That means we increment our latest count. Else, if it's not equal, then we just basically find the max. And then we just make that the number. So it'll be the max out of all the dynamic programming we have so far. And then this, we want to find the last number minus 1 because we added 1 here to avoid the edge case where they're not equal to each other in order for us to do this dynamic programming array. So overall time complexity is big O of m times n because we have this product for this for loop iteration through a product of m times n. And space complexity is also, we have a dynamic programming array of m times n as well, or m times n. Alright, that's it. We should probably submit this. It's accepted. Alright, that's it. Have a great day, guys.